on big data as a research area and opportunities. Welcome our today's expert, Dr. Ankit Shah. Dr. Ankit Shah is the HOD of CE and IT department from Sankar C. Waghela Bapu Institute of Technology in Gandhinagar, and having a very good knowledge about this particular topic. So welcome, Dr. Ankit Shah. You can start with your webinar, sir.
Okay. Thank you very much, sir. Am I audible?
Yes, sir, enough audible.
Okay, fine. Thank you. So, very good morning, all of you. Our today's topic of discussion is about the big data as a research area and opportunities lies inside the big data. Now, if we see a bigger picture in terms of big data, then it is a branch which is not only related to the computer science and engineering, not only related to the IT, but it lies a deep root inside any of the engineering or science background. So you can connect all the research areas which lies in the form of a data, where in case you can connect with a medical line, you can connect with in the terms of business perspective, you can connect with machine learning, artificial intelligence. So it is a broader picture. So if we look inside a detail, then each of that particular topic has a different root inside of a research perspective. So today in our session, we'll be discussing about how you can incultivate that kind of topics as a research, and you can pick any of that topic to do a master's project, to do a PhD research work, or as in bachelor also nowadays, big data has been introduced. So you can choose it in your final year project. So today's agenda of discussion is about why big data. What is the need of big data in terms of processing and as well as in terms of analytics? Where big data is being used. So we'll not be discussing about the applications area because we all know that which are the different perspective of applications area are available. But we'll discuss about that how these application areas are deeply connected with the research perspective. Then we'll discuss about the big data used into the real life problems. And at the end, we'll be discussing about the big data related open research issues and how big data can change our future. So let's start with definition of big data. Now we all know that big data, it is a kind of colossal amount of data which is difficult to process in terms of storage, in terms of processing, in terms of managing this much amount of data. But if I see a big data, then rather than going for the bookish definition, I would say that big data is a data which is larger than the capacity of a computer. Which means if I am having a computer which is of 1 terabyte of storage capacity and 4 GB of processing capability or RAM. So in that terms, if I am having a data which is larger than 1 terabyte, then for me or for my system, that is a big data. So if we put it into the simple language, a term by term, it is nothing but a huge amount of data, and we do not have a capability to process that data. So when I say this larger amount of data, it opens up broad perspective. So in today's big data technology, thousands of data which is coming continuously from various sources. If we talk about the various sources that are e-commerce, that are online platforms which are available, sensors are available, right? So our day-to-day digital lives are connected so much in a different way that it is difficult to empower this kind of data with our regular day-to-day technology. So that's where the power of big data comes into the picture. So if we see a picture of 4 V's, we all know about it. So rather than 4 V's, sometimes it has been said as a 5 V's or 7 V's, depending upon the usage of that particular big data. But is a big data is an engineering problem or a science problem, which is a pretty much tricky answer, right? So big data, it is not only an engineering problem, it is not only a science problem. So when I say an engineering problem, that connects all the engineering branches. And when I say a science problem, that is, we know that engineering is a branch of application-based science. So science is a core science, right? So in that terms, how we assemble an architecture which supports a big data in terms of scalability, it is an engineering problem. So if we see these 4 V's of big data, which is a variety, volume, velocity, and a value. So if we go term by term, variety of data. So nowadays we know that data is not only comes in the form of structured. So in older days, we know that data was in the form of structured data, wherein we are having fixed amount of rows and fixed amount of columns. and it has been increased according to the number of value has been added. But that was the structured format. So in nowadays scenario, we cannot imagine to have a data which is always into the form of structure. It is in the form of semi-structured as well as it is in the form of unstructured data. So what I mean by unstructured, that is a kind of audio visuals data, like right now the video streaming is going on. So you can imagine that that sort of data, it is completely in unstructured format. So how to handle this data? How to get benefit out of the colossal amount of data? So that is lies inside the varieties of data we have. Then the volume of data. We all know that the size of data which is being generated on day-to-day basis from various digital platforms. If we talk about the CDR records, if we talk about the search engine records, if we talk about the social media platforms, so these all platforms are generating huge amount of data. So volume, it is one of the problem which lies inside the computer engineering problem. So that solves how you can process this huge amount of data. And the third one is a velocity, the speed of data which is being generated. According to the IBM way back in 2030, it has been stated that in last or past 2 years only, 80% of data has been generated. So you can imagine that within, and that was a statement of 2013. So you can imagine that after 7 years, how much data that we have generated. So that is the pace of the data. So how to maintain this velocity of data, and parallelly we need to identify the logic behind it, how you can use that huge amount of data. And the fourth one, that is a value, and that is a core, you can say it as a data science problem, or the data scientists are working on to the value. So how we can get benefit out of it, how we can visualize that particular things, how we can use the data that we are having for the perspective of business, for the perspective of jobs, for the perspective of education, or any of the application which lies. So ultimately these four V's, one more V you can add it as in the form of veracity, wherein how the data which we are getting which is accurate. So again, that is a computer engineering problem. So ultimately big data, it is not only a computer engineering problem, it is all two sides of coin are there. One side you can say it as a computer engineering problem, on the other side you can also state it as a data science problem. So these three problems must have their solutions also. So in that terms, all these three problems have three different solutions in three different perspectives. The first one is how to manage this high volume of data. So for that, we have a picture of batch processing. So wherein in the case of batch processing, the data comes in the form of small batches of amount. Now, when I say small batches, that is not in terms of 1 GB or 2 GB. Obviously, it is in terms of terabytes or petabytes. So that data comes in the form of batch, and that has been distributed by the various platforms are available like Hadoop, Spark. So nowadays, so many open source platforms are available which deals with the processing part. So this huge amount of data comes in the form of batch, and it has been distributed by the distributed system over the various number of clusters. And then comes the variety of data. As I said, the data that we are having, that is in the form of structured, unstructured, as well as in the form of semi-structured. So that's where the picture comes into the NoSQL database, which is not only SQL. So it not only supports the fundamental part of structured database, but it can also handle the unstructured database, wherein you are not having fixed amount of columns for the number of rows. So there are chances that in one row you are having 5 columns, and in another row of database you are having 10 or 1,000 number of columns. So it is not in the form of fixed structure. And the third part, which is a velocity, wherein the pace of data is very much important. So data is coming so fast, wherein you would require to take necessary action at sometimes online as well as sometimes real time also. So there are two terms which is comes into the picture, which is online processing, another one is real time processing. So these two terms, you may feel that both are same, but we'll see into the next slide, these two terms are completely irrelevant, or these two terms has a different meaning. So velocity comes into the picture, and that's where the streaming processing comes in as a solution. So as the pace of data is so fast, we need to find a solution for the processing, wherein the data gets processed at real time. So how the data will get processed real time, that depends upon an application and the tools that we are using. So we do not require a solution which is only provides a batch processing. So as I have said, batch processing, it is something like wherein you are having a solution which is a kind of in offline mode. Fine. So data gets updated, but you can process it and the latency has been allowed. While in case of stream processing, data gets processed at real time. So it is very much important that the stream processing should take necessary action at real time. So if we see overall picture of harnessing of big data way back from starting from 1968 till 2020, then we can start with the old terms of database, wherein in 1968 we were having information management system. So basically that was being introduced by the IBM, and it is nothing but a concept of hierarchical database, wherein you are having a one parent node and multiple child nodes. So structure is something like a T structure. So in that particular sense, database was handling a kind of structured database only. So the fixed amount of rows and columns are there, and that has been managed by the hierarchical structure. So, and then in 1970s, the picture comes of RDBMS. So basically that is a relational database management system. So wherein in first case of hierarchical database, we were having a kind of a tree structure, and here the picture actually comes that till date we are also using DBMS depending upon an application, which is basically a structured organization of data. What I mean by structured organization of data, that is our SQL database, MySQL database, wherein we are having fixed amount of schemas are there. So according to the schema, we'll be having fixed amount of columns, and accordingly data will get upgraded by the row. So that comes in 1970. Then after in 1983, the concept of data warehousing comes into the picture. So basically it is an idea of how this huge amount of data can be managed, how it can be placed at a single location, and it can be distributed among the multiple users. So that's where the data warehousing comes into the picture. Then from 2000 onwards, string computing comes in, where we would require to analyze and process the data in real time. Right? So if you see that up to 1968 to 1970, it was an era where a kind of online transaction was done. So it is kind of OLTP, where online transaction processing can be done. From 1983 onwards till era of 2000 or in 2020 also, we are using the concept of online analytical processing, like a concept of data warehousing. Fine, we know the concept of cloud computing. And then 2010, that's where a real-time processing comes into the picture. So as I said earlier, that online analytical processing and real-time analytics processing both are different things. So how they are different or how they are apart? So if we compare in terms of online analytical processing and real-time, so we can say that in case of online analytical processing, some amount of latency is accepted, which means if you want to store a data over a cluster or a cloud, then if it gets delayed by 1 or 2 seconds, then it's fine. It does not make any difference in terms of processing. But in case of real-time analytics or real-time processing, the immediate decision or immediate output of the data which we would like to process is very much important. If I give you a simple example, if I move my mouse, then we are expecting it to move my cursor at real time, which means it should not be like that. If I move my mouse here and then here, then it gets delayed by 2 seconds or 3 seconds. Right? So that is a real-time processing. But in terms of online analytical processing, if we take an example of like right now my video stream is going on over the Facebook, and in that case it is allowed if it gets delayed by 2 or 3 seconds due to a network delay or due to whatever the circumstances. So in case of online, so it is a kind of online analytical processing platform wherein I am delivering a session or a webinar, then and you are on the other side, you are listening it. So in that case, latency is accepted, that's fine. But in some cases wherein you are making an online payment, and once the payment has been done, it should immediately reflect onto your bank balance. So that is actually a real-time processing or real-time analytics. So both are a different perspective. Yes, it feels like that online is also real-time, but yes, you can have some amount of latency in case of online analytics, while in case of real-time, it is pretty much clear that no amount of latency should be there. So why we need to see a bigger picture of big data? Why big data is very much important? So in today's age of data, where companies looking for various business perspective and they want to analyze and they want to maintain their customer relationship also. They want to see that which are the different customers are regularly buying from a particular vendors. If we see an example of e-commerce, so we all know that in case of e-commerce, whenever you access any of the particular product, it immediately comes into the clickbait that if you go for after accessing your Flipkart account or your Amazon account, if you move towards the Facebook or your Google page, it immediately shows that particular product onto your web pages. Why? Because you have demonstrated an interest into that particular product and they want to capitalize that particular thing, that as you have shown an interest on that particular product, if they're bombarding that kind of advertisement onto your web pages, then there are chances that customer will buy it. Now there are chances will also contain the percentage amount of user which gets attracted through that particular advertisement. So they have a clear picture that how many number of users get attracted through their advertising over the digital platform or over the whatever platform that they are using. So they need to kind of analyze your each and every activity over a digital platform. Then and then they'll be having a kind of figure that if they go by this particular perspective, then there are chances that their business will grow up. So on that particular customer perspective, on the user perspective, why big data is important has been categorized in 4 different categories. The first one is a data science perspective. In terms of data science perspective, we are having enormous amount of data. Now, how to use this data, how to get benefit out of it, how to analyze, how to visualize this data, that is a data science perspective. So for that, we are having a data scientist who manages this colossal amount of data and getting some benefit out of it. So that is why big data is important as data science perspective. If we see another perspective as in the form of business perspective, so how you can make more business out of the data that we are having. As we all know that nowadays we are getting continuous calls for the credit cards, for the bank loans and something like that. So how they are getting this? How they are making business out of it? Obviously they are having a data, and from that data they are identifying who are the potential users or potential buyers of their loan or potential buyers of their credit card. So that is the business perspective. The third one is a real-time usability perspective. So at real time, how this big data can be effective. As I have given an example of e-commerce. So that is the kind of real-time usability of perspective, wherein users are accessing a particular website for buying some kind of goods. And after that, if he or she does not buy, then it tries to give that sort of advertisement so that they get redirected over that particular platform for buying a particular product. And the fourth one, which is a job market perspective. So nowadays we all know that there are so many jobs are available due to the big data. Because in old days, if we talk about just 10 years or decade back, there was no such need of big data because we were in a situation that that data can be managed easily with our commodity hardware that we are having. What I mean by commodity hardware, which means our consumer systems, desktops, and laptops. So we can imagine that yes, it can be done by our normal day-to-day system. But nowadays there is a huge demand that a big data analyst or big data engineer or data engineers are required, to visualize this kind of things, how they can make business out of it. So in terms of job market perspective, also big data plays a major role. So these are the 4 perspectives. Now again, when I say a research, then all these 4 perspective has a different demand or different application areas wherein you can find your research area. We'll be discussing more about the research, that how these 4 concept or perspectives of big data can be combined together to make a kind of research topic out of it. So that we'll be discussing. So where this big data? So as I said, big data is a bigger picture. If I see a small part of it, then big data has a kind of 3 different kind of pillars, wherein one is a big data science, another one is a data analytics part, and the third one is big data computing, or we can say it as a processing. So again, this three are in such a way that each of these pillar has a different areas of research. If I talk about a big data processing, then there are various tools like Hadoop, NoSQL, Hive, Spark, Plume, which tools have a different algorithms, which these tools are having different scheduling approaches, and you can find out some flows out of it, and you can make one research point out of it to make your bachelor's or master's or PhD topic according to the size of the project that you are choosing. So basically, big data computing, it refers to the huge amount of data in the form of structured and unstructured, and you need to find out how you can mine those data, and you can analyze it for the perspective of communication, for the perspective of business, for the perspective of finance or something like that. So these are the things which are divided in three categories: that what is that particular big data, what are the different application areas, and what are the different tools and technologies are available. So accordingly, you can be able to choose a particular research topic on which particular application areas you want to target upon. Right? So you may feel that yes, financial services are there, so that would require only the form of kind of harnessing the big data, processing the kind of ETL process wherein extract, transact, and load kind of functionality is there. So that's where the picture comes into the finance. But there are certain situations like here the examples are given like gaming, healthcare, digital, wherein not only processing of data is important. Later on, after getting data has been processed, it requires some sort of analytics also to be done, and then after the data science. So this is a chart which kind of in terms of processing goes from right to left. We'll see the big data life cycle. At that time it will get clear that how this data has been processed, analyzed, and then how you can use it for the conceptualize or analyzing it for the business perspective. Then after, the second comes into the big data analytics. So data analytics is the process of examining the data sets in order to draw a conclusion. Fine. So you need to examine the data. It is something like that. Let's say, for example, if we take an example of education system, wherein some of the universities, like if I talk about the Parallel University, they are having student strength around 10 to 15,000 every year. Right? So in total, if I combine the mass of 3 to 5, only 5 years, then they are having a database of approximately, I may be wrong, 50,000 students. And just imagine the size of that database wherein 50,000 students information has been stored, their results have been stored. There is a deep inside it. And apart from that, whatever the curricular, non-curricular activities they have stored. So that particular database demonstrates the overall structure of, students. Now, how to analyze the student's strength, how to analyze, past 5 years of business or past 5 years of education system, that what is the transition has been done by the Parallel University or XYZ University in terms of getting more education, or in terms of giving more education to the students, or in terms of giving more ideas to the society. Right? So they need to analyze that what they have done in that past 5 years. So they have a database. Then after that, they have to scrutinize, or they need to kind of cleaning of data is required. Some of the data that may not be useful in terms of giving us a precise result. Let's say, for example, that out of the 50,000, let's assume that only 500 or 1,000 data has been of no use, which means that student has taken an admission. After that, he left out, or whatsoever reason, he is not continuing his study. So that particular data would not be useful. Yes, obviously that is being useful to identify the dropout ratio and all these things. But in terms of how they have cultivate that particular knowledge to the student, at that time that 1,000 database is of no use. So that is the point we need to highlight, that how to analyze this data. And once we analyze that, we need to get some valuable knowledge, or information extraction is useful, and that's where the data science is useful. So they need to identify that these are the ideas that have been cultivated through the education among the students, and out of that 50,000 students, how many students are going for the further studies, how many students are being retained by the university for further studies, or something like that. That kind of analytics can be done, and at the end that can be deployed in terms of getting more business, or getting more research activities, or something like that. So that's where data analytics, and then after the data science. And data science is a field that refers to the collectively process the theories and concepts and review it for getting valuable knowledge. So as I said, these three terms are related to the big data, but has a different perspective. Big data computing, which is basically a processing part, analyzing, which is basically once we get the important information, you need to analyze it, and then you need to capitalize this analysis for getting more business, for getting more, kind of crowd towards the data science. And these are the tools that plays a major role for different perspective of different pillars. So this is the broader picture of analytics process, wherein we start with identifying the business problem. So if we want to use a big data as a technology, then we need to see to it that what is the business problem that we are targeting upon. As I have said that if we want to go for the healthcare, then there is a different set of tools are available. You need to make sure this how this data can be used or something like that. If the same data set is available, let's assume that if I am having a data set of the Gujarat-based city, Gujarat-based population, out of that, if I am targeting for the advertisement of, let's say for example, chocolates, then usually if I see a picture of in the form of company who is targeting their audience, then they would target the target age from 5 years to 30 or 40 years. Because why? Because they want to see the maximum benefit out of it. The same group of people, the same database, if there is a product which comes for the age from 30 to 60. So for them, let's say for example, bicycle, or let's say for example, any car is there. So for them, the target would not be a person who is having an age of 15 years or 20 years. Their target would be from 25 to 50. Why? Because they want to make business out of it. The database is same, but how you utilize that particular data sources, that is very much important. And that's where this analytical process model comes into the picture. So starting from a business problem, we need to say for which particular application or for which particular business problem that we are targeting this particular analysis model. Then identifying the data sources. We need to see that which are the data sources are available for this business problem. If it is related to the healthcare, then we must have the database of thousands and millions of patients, so we can analyze that particular data set for getting, kind of developing some new technology or developing some new idea out of it. So you need to make sure that you must have the data source. After that, you need to select the data. As I have said, you are having bunch of information. Out of that, it is depending upon your application, and you need to identify that which data source is important for your business problem. And then after cleaning the data, we need to identify some important information. So some of the anomalies that we need to remove, and that's where the fourth V comes into the picture, which is a veracity. Right? So whatever the information which is useful to us, or the information which is correct as per the standard, we need to keep it, otherwise we need to discard it. Then transform the data according to our use, we need to transform it, and that's where the process comes into the ETL. If we go by ETL, this is extraction, then transformation, and then L, or load or learning. So the first 5 parts, starting from identifying problem to the transformation of data, that is a research area of processing, right? So if you have selected your topic in the form of big data processing, so it is not important that how you analyze those data. Your target is only for the processing part, which means you need to, optimize the performance. You need to add a value addition to the existing algorithm. Let's say, for example, you are adding some new scheduling algorithms. So all this picture comes into the processing part. So that's where the research area you are targeting upon. The next comes into the analytics part. You need to analyze this data. Once you get the data, you need to analyze, you need to apply the various machine learning algorithms. You need to see to it how you can utilize this data for getting more business. And then post-processing part, which means once you have cleaned the data, you have analyzed it, you need to evaluate a particular model which you can deploy to the real-time application, which means, let's say, for example, e-commerce, right? So if I connect this particular model with e-commerce application, so starting with, you need to to get more business by the advertisement. That is my business model. That's what I want to target it upon. So I'll see that if I am able to supply my goods all over India, then my data sources would be Indian region, fine, or the people of India. If I am making a business globally, then my target of data source would be all over the globe, all over the world. After that, select the data. As I have given an example that according to your product, which particular product and according to which particular type of people you are targeting upon. If I say in e-commerce, then e-commerce is targeting their users whosoever has access a particular product, or they have seen this particular product, or they are looking for it, for buying it. Right? After that, cleaning the data. Some of the users have already bought that product, or some of the users have seen or given a kind of comment that he or she is not more interested onto that particular product. Sometimes we see that, right? That in case of Google ads, you have an option that you do not want to see this kind of advertisement. So that kind of data has been cleaned because they don't want to target the people who do not want, or those who are not interested to buy that particular kind of products. And then transform the data for their particular applicability, analyze it, and then finally provide a more business model so that they can get maximum benefit out of it. And this is the overall life cycle. Now, in this overall life cycle, each of the square boxes that you are seeing right now is one of the research area. Fine? That research area may be in terms of an application, maybe in terms of data science, maybe in terms of programming or something else. Fine? So we'll be discussing about, this is a kind of, we can say that it is a data value chain. How you can get value out of the data, which means a broader picture, it is a data science problem. Right? So starting from data generation. So first and foremost step comes into the data life cycle is a data generation. What is the source of data? From where we are getting this data? Fine. So if we see it, there are various options that we are having: e-commerce data, social media data, scientific, healthcare related, finance, telecom. In case of telecom, CDR, call directory record, or something like that. So this particular data generation, these are the source of data, wherein we are getting humongous amount of data. Fine. So again, this is one of the research areas that how you can get more amount of data, how you can design an algorithm for getting an information from these many platforms. So that is also one of the research area you can think of in case of big data. And then after a data collection, fine, data has been generated, but afterwards what? We need to collect it. Fine. So how we can collect the data? We can collect the data of log records. We can collect the data of sensors, various sensors. Nowadays, smart city comes into the picture, wherein various sensors are installed over the city, and these particular sensors are continuously generating a data. So once the data has been generated, after that, it is very much important to collect the data and process it. If you cannot get anything out of this data, then there is no use of simply storing the data. Ultimately, it occupies more amount of the space onto our system. Then a web crawler, fine. Search engines are using it very much for the getting the information of new web pages which is being added, so that they can list those pages for the search. And network monitoring system. So these are the various points you can think of for a data collection perspective. Then once the data has been generated and collected, it is very much important to transmit those data. So for transmission, we have inter-DCN and intra-DCN transmission, wherein data has been collected. After that, it has been transmitted on various platforms. Right? If we talk about IoT, so wherein various sensors are installed, then using a concept of IoTs and cloud computing, and nowadays fog has been introduced. So it collects the data from various sources and transmit it over a cloud, over a fog for the processing part. So where you are transmitting those data, that is also very much important, right? If it is a big data like social media platforms, if we talk about Facebook or Twitter, wherein millions of tweets, millions of posts being posted over the Facebook accounts. And once it is being posted, there are video files, there are audio files, there are images, textual information. So we need to process it. As we know that in case of YouTube also, there is daily approximately 10 trillion amount of data which is being generated over a day on just a YouTube platform. And we know that YouTube is continuously monitoring, and that's where it is basically an online processing. It is not a real time. So it manages sometimes if the video has been uploaded, which is not according to the law or according to the terms and conditions set by the YouTube, they remove that particular video, fine, due to the copyright action or due to whatever the reason. So once the data has been uploaded over the platforms, it is very much important to process it. And data processing, it is very much important part of big data. If we talk about the integration, wherein you are having, various data sources are there. From various data sourcing, you are integrating those data, especially in case of IoTs, right? So various sensors are installed over various locations, and you are combining those data. You integrate those data, and then you visualize it. Cleaning of data, elimination of redundant data, feature extraction. So each of this is basically a task of computer engineer or a computer science people, wherein you try to identify that how you can use this data effectively. Because if you are having 10 terabyte of data, we all know that out of this 10 terabyte, if we go for the processing of 10 terabyte, ultimately it will take more time. So is there any way that we can reduce this 10 terabyte data in smaller chunks, smaller size, rather than 10 terabyte, even if it gets reduced to 5 or 6 or 8 terabyte, 2 terabyte that we are discarding, that is of no use. Just like an image compression. In case of image compression, what we are doing, we try to reduce the size of an image without, there are two concepts which can correlate, lossless and loosely coupled. So in this particular case also, we need to make sure that the data that we are discarding or that the data that we are cleaning, if it is of no use, we can eliminate that data, and then after we go for the processing part. Feature extraction, it is a very good branch of a kind of mining, as well as in case of visualization, image processing. So again, it is a kind of a branch which lies deep root inside the big data. If feature extraction is a part of wherein you are having millions of records, and if you want to extract the feature out of that record, so that's where a big data processing comes into the picture. Then a data storage. So in terms of data storage, there are various platforms which are available for storing the data over the distributed platform, starting from GFS, which is basically a Google file system, then HDFS, Hadoop Distributed File System, Dynamo, Bigtable, which is very broadly used, Cassandra, which is being used by the Facebook, Couch database, and Trayer. So these are the various data storage platforms are available. Again, each of these platform has many different types of research applications wherein people are working on, and you can also find various research gaps inside these various platforms. If I talk about HDFS, nowadays HDFS and Spark, which is broadly used. GFS is basically for the purpose of Google only. So, but HDFS and Cassandra and Spark, these are the open source platforms wherein you can make changes into your existing source code. You can design your own technique. If I talk about HDFS, there are various flows in terms of data storage, in terms of performance. You can find out that particular research gap, and you can deploy your own for the storage or for the processing of big data. And next comes into the data analysis part, wherein each of these for the identifying research problems, data mining, text mining, multivariate statistical analysis, social media analytics, network analytics, multimedia analytics. So starting from data generation till data analysis, we harness the value from the data. Harnessing the value, which means when we are having a raw data, it seems like it is of no use. But when we see the final output after analysis, we feel that yes, these are the data which is very much helpful to get more business, or we may get some more insight about the data. So the conceptual, if I classify this kind of data life cycle, in the form of conceptual, therein three challenges we can look into. Again, this is the picture which targets upon a research perspective. Fine. There, data challenges are there, process challenges are there, and management challenges are there. So how you choose your research topic, that is very much important, because in case of your bachelor's or master's or even in PhD research, it is kind of pretty much difficult to target on all these three perspectives, because otherwise it may take 5 to 10 years to complete the wholesome product for conceptualizing all the challenges. But you need to pick the challenge in such a way that that would fit according to your capability. So starting with data challenges, how you manages all these V's. As I said, there are many V's: volume, velocity, variety. So you can target any of these V's, and you may feel that these are the challenges you can target upon, and you may identify some of the research gaps for the solution of the data challenges. How to handle this huge volume of data at the time of generation, or at the time of processing, or at the time of storage, that you need to look into. Then after, a processing challenge, which means data acquisition and warehousing. So if you are targeting upon an algorithm to solve the challenges which lies into the data warehousing part or mining part, then you are into the area of big data processing challenge. Fine. So if you are simply storing it in effective way, then you are into the area of big data kind of computing. Then after, big data processing, wherein how the data has been processed or identifying the various business models, that is a part of processing. And big data management challenges are how you can improve the privacy, security part, data governance, then cost operations, and data ownership, data information and sharing. So these are the managerial challenges that we are having. So you need to be very keen while choosing a research topic out of the particular area, that which particular area you are targeting upon, and based on that you need to choose your tools and technologies wisely. Right? So again, in terms of research objectives, the challenges that we have seen, and according to your objective, we have categorized your big data research in 4 different objectives, starting with the first one, which is a big data analytics. So if your objective about the research, it is of large scale machine learning and data mining or visualization part, then your objective is about a big data analytics. The second objective is about the big data computing, wherein you collect the data from various sources, you transform the data, integrate it, or distribute it among the multiple clusters. Then your research objective is about the big data computing. If I give you an example of, I'll give you an example of my topic, wherein I targeted upon the big data computing. My area of research was, performance optimization of big data using heterogeneous distributed computing. So wherein what I did was, how the data has been collected. Once I am having a data which is of 100 GB of size. So how to store this data effectively? Because if you conceptualize the application area for processing, it is very much important that your slave nodes, or in terms of Hadoop, it is known as a data node. Your data nodes must have to be so much powerful, they can give you an effective performance. So by default, in case of HDFS, there is no such facility which is available wherein you can choose where to store your data. So in case of HDFS, if I go to store 100 GB of data, and if I am having a 50 nodes, then it randomly places this 100 GB of data over my 50 nodes. So there are chances that out of this 50 nodes, obviously my topic was on heterogeneous, then my cluster must have to be heterogeneity, which means some of the systems are running on Windows platform, on Unix platform, or they are having different configurations in terms of networks, in terms of hardware and software. So basically it was a kind of a distributed environment with heterogeneity. So the bigger picture is that how to store effectively, because if my data is stored in a situation or in a system which does not have a capability, which means it has a capacity of only i3 with 2 GB RAM, wherein my rest of 49 systems are having Xeon 5 processors with GPU. So obviously, if my data is stored into the system where that much processing capability is not available, then that kind of system is of no use when performance is very much important. If I am targeting only onto the storage, then that's fine. But my target was not only on storage, my target was also onto the processing side. So what I did was I defined my own HDFS block placement policy, wherein I'll be able to choose a specific data nodes where I want to store my data. And after that, I'll be able to choose my own processing nodes also. So I know that out of that 50 nodes which I am having, which of the particular node which is having a low capability in terms of processing, in terms of storage. So I discarded those nodes, and then after I select only those nodes which has a processing as well as storage capability. So that was not there, and that is not being there in today's even by in default HDFS block placement policy. So that is all about the big data computing, wherein you collect, transform, and integrate this data, and how you want to process it. According to that, you can choose your research objective and research title. Then onto the theoretical part, big data theory is there, wherein you can use some of the sampling and statistical theory, and you can identify some security loopholes, privacy, and you can try to improvise those concepts. And the fourth one, research perspective, that is big data science, wherein some of the analytics parts and engineering part of is can be covered for identifying the research problems, for analyze the data that we are having. Basically, big data scientists are working on this particular big data science concept. So this is the SWOT analysis of big data. What are the strengths of big data? So it helps research-oriented topics for analytics. The major strength of big data that it covers not only a computer science branch, but it covers all the digital platforms where data which is being generated. And as we all know that there is no single digital platform that which does not generate a data. Fine. So as the data is generating so fast, one of the major strengths of big data, it is there are various areas of research topics are available, and it is continuously growing. Open source community, as this is very much important, that whatever the tools are available for big data processing part, majority of tools are open source. So there is a huge community which is available to us, who can solve to us or who can solve our doubts. Sometimes when we are new to the particular platform, there it is an open source. Obviously, so someone has already worked upon it, so that particular community can help you to identify some of the research problems, or you can identify that research gaps by your own, and you can explore it for getting more business or more research oriented topics out of it. And continuously it is opening new era of big data. Some of the weaknesses also there, lack of technology support. As I have said, that till 2008, if I talk about, then there was no such tool which was available for processing those big data. Fine, because we have our data, but how to process it, and even if we can process by our regular servers, the solution that we are getting, which is taking much more amount of time. Let's say, for example, if you want to solve some kind of problem which is related to the science problem, or which is related to the healthcare, if you are getting a solution of processing data after 2 days or after 10 hours, then that kind of situation may not be useful for identifying the important things out of the data. Fine. So sometimes it is okay if your application is in such a way that you can analyze it in batch, then you can obviously rely upon it. But sometimes it is very much important to take decisions at real time. Fine. So data science problems are such that real time processing is required. So there is a weak support in terms of that thing. Again, lots of unstructured data is present over a social media or over the various platforms, and there was no such technology. And obviously today we are having such technology which is available, but still it is in growing phase, and continuous monitoring is required. Fine. So that is one of the weakness you can consider. There are various opportunities that you can utilize or you can capitalize upon. People look to use the new paradigm of the shift from the unstructured form of data to the structured form of data to the unstructured form. then opportunity of processing rich data, getting the maximum opportunity in terms of business, in terms of healthcare, and various platforms are available. And some of the threats, as I said, it is an open source, and the tools are continuously upgrading. Then there are obviously bugs comes into the picture. So there is the threat of cyber threat in terms of your when your data is distributed among the multiple systems, then there are chances that someone may identify that bug out of it and capitalize it for the other vision or other perspective of this data, right? And whenever you are garbaging some of the data, which means you feel that this data is of no use or this data is garbage data, then during the cleaning time there are chances that you sometimes you miss the important part or core part of the data. So various techniques are very much important to identify according to the problem. When you are cleaning the data, your cleaning of data application must have to be according to your need and according to the requirement of an application. Then various job opportunities. If I talk that there are so many job opportunities are available in today's market for a big data developer according to the skill that you are having. As I said, overall for perspective, starting from big data analytics to the data science, then what you are having as knowledge, accordingly you may get various opportunities like big data analytics or analyst, big data architect, data scientist. If you are familiar with tools like Hadoop and Spark, then options of Hadoop developer or Spark or something like that can be open your door. Big data engineer. So these are just some of the job opportunities which you can create by doing research. Now, this is very much important that what is expected as your research outcome. Fine. You have chosen your research topics, but your research topic must have to in line with the expected outcomes, which means you have defined that this is what I want to do. But if it is not expected by the current business perspective or current scenario, then again that research is of no use. So your research topic must be in line. I have categorized this research problems into the application, which means as I've given an example that if you can design a new algorithm of data over a cluster, if you cannot correlate to any of the application, then again that research is of no use. And that's why when we choose any particular research topic, we must need to correlate or identify the relevance of the technologies. You must choose one of the application on which you are trying to apply that algorithm, and you prove that yes, these are the new methodologies which may improvise the existing one. So that is the first research outcome which is being expected as a research scholar from any of the researchers. Then designing your own application, that is again a new perspective which you can open, right? Identify new applications over the engineering problem, over the social platforms, how you can benefit to the society, how your application may benefit to the society. Choose your application itself as a research problem. Then you can, kind of apply it in the form of new digital economies, how you can, useful to the real-time practices. Like nowadays, we all know that blockchain or cryptocurrency, right? So it is in such a way or being used by majority of countries that again that is a kind of area of big data wherein the data has been distributed. That's what the concept of big data or distributed computing, and that's what is there in case of blockchain also, wherein your data has been distributed but in the form of chains. We are not discussing about blockchain, but the thing is that you can identify such research in such a way that how you can add on your knowledge or add on your research perspective for adding it into the real world, so that majority of mass can be connect together for your research. And new educational programs for the students, obviously, as this has been introduced in way back in up to 2015, even I would say, this kind of topics were not there in terms of syllabus in bachelor's level, in master's level, or not even in PhDs. But nowadays, people are choosing this kind of educational programs, as it is targeting not only social platforms, not only social problems. It also targets upon an engineering. It also targets upon broader spectrum of science people. So these are the expected outcomes being a researcher of computer science or being a researcher of big data, which is expected from the researcher. And again, as I've said, there are so many perspectives. So basically, big data, it is, it is not an individual task. It is a teamwork, wherein your problem of research must have to correlate with the current industry need, or in the terms of serving to the society or the academician. So big data analytics is necessary, must have to be a joint effort of researchers and academic institutes, or government and societal, as well as to the industry side. So if we all combine together, then obviously there are so many things to be harnessed from big data, in terms of getting more knowledge, in terms of getting open up more research areas, in terms of getting more business out of it. It is just a way that how we look at the bigger picture and how we try to solve the big data problems for the purpose of research. So to conclude my today's session, what we discussed is how big data has been developed and how it can be harnessed individually. Being a researcher, it is very much important that whatever the problems that you are targeting upon, it must have to be conceptualized in terms of current need. So how you can make or characterize the use of big data in terms of getting profits, in terms of getting challenges or solve the problems, that's what we discussed. In addition, we discussed about the various issues of various societies, or how we can display or analyze these big data techniques. And at the end, it basically I try to enhance the research point of view, that how you can choose your research topic. See, there is no point to discuss the research titles, because obviously it lies deep root inside each and every topic. But the thing is that it is very much important that when you choose your topic, you must need to capitalize on one of the spectrum of the particular big data which you can solve. So thank you for joining. Here I conclude my today's session. In case of any doubt, you can contact me on this email ID.
Sir, I'm connecting with the audience for the questions from the audience side.
Sure. Yeah, definitely.
Okay, sir. There is one question is that you are talking about the data cleaning. So whenever we are doing the data mining, okay, so we are gathering the data for some purpose, right? So
Yes.
What are the parameters we need to take care of when we are cleaning the data?
See, obviously, when you are getting a data, you do not have a control on it. Let's say, for example, if you are collecting a data for an healthcare application, or if I give you an example of smart city. So at the time of collection, you do not have a control. If we are continuously monitoring the weather, or we are monitoring the air quality. So at the end side, when the data has been collected, we do not have actually a control over it. But once we get the data, it is very much important that on which particular perspective you are targeting upon. Let's say, for example, if you are targeting upon the air quality or monitoring the air quality of XYZ city. So you need to be assured about that your data must be in line to this particular range, which means that if it is the temperature data, then we all know that there are some anomalies when you are collecting a data. Sometimes due to the sensor issues, that particular sensor is showing a data which is of, let's say, for example, 45 degrees. But if we look at the nearby point or nearby sensors which are there into the smart city, which is showing only 30 degrees. So we need to be assured that yes, one of the particular point is showing 45 degrees, and there must not be a particular point which is only of 45 degree and nearby points are showing 33, which means there is some anomaly, your data which is not clear. or your data contains some data which is not actually being expected. So what you need to do is you need to finalize the fine line between the cleaning of data and discarding of data. So once you clean the data, you need to be assured that the data that you are having for the purpose of processing, that must need to be according to the standard that you have set. Fine. There are chances you cannot clean 100% of data when you are cleaning the data, but it should be in such a way that the data that you are discarding, that should not affect the overall structure of the data. I hope.
Okay, sir. Yes, sir. The next question from the viewer side is that whenever we are cleaning the data, right? Whenever we are taking care of the particular data, so if there are some missing entries, must be there into the data. For example, we have the 6 temperature data, as you are saying right now, or some of the data is missing over there, or maybe, or there is some not a unit is also different over there, or something like that. So how we can deal with that situation, sir?
See, these are the things which is bound to be happen, and as we are dealing with data, you cannot rely on data on 100%, and that's why I said that if we are dealing with the data, as you rightly pointed out, and as I said earlier also, that the temperature data is missing, and that's why the picture comes into the big data, that you are having bunch of data. If one entry is missing, if your overall solution is not gets affected, that's fine, your one entry is missing. When you are performing, if I correlate this example in terms of a map reduce program, then if you are mapping your data and if you try to reduce it into the final form of cleaning, at that time some of the entries definitely is going to be missed. And there are various algorithms are also available that if you want to fulfill out that particular entry, then nearby points you collect, and according to the best average you put it into that particular table entry. But again, if when you are dealing with big data, at that time that's fine, that if you clean the data, if you are having a data which is not there and still you try to process it, as far as it does not affect your overall performance, it is expected that it is there. And you cannot, again I'm repeating the same thing, you cannot clean your data 100% by removing all the anomalies.
Okay, thank you so much, sir. I think there is no further questions from the viewer side. Sir, thank you so much for this valuable knowledge regarding this particular topic. Behalf from the Parallel University, I'm thanking you a lot. And behalf of the PIT Computer Department, I am thanking you to give your presence in this wonderful webinar, sir. Thank you so much, sir.
Thank you very much.
Thank you so much, sir.